In the hidden depths of the quantum world, there exists a class of entities so fleeting, so ephemeral, that they seem to exist only in imagination. These are virtual particles, the ghostly actors of the subatomic stage. Unlike ordinary particles, they cannot be directly observed, yet their influence is tangible, measurable, and profound. They emerge from the vacuum itself, popping into existence for infinitesimal moments before disappearing back into nothingness, mediating forces, transferring energy, and shaping the interactions that govern the universe. Virtual particles appear in every corner of the cosmos, in every atom, in every interaction. They are responsible for mediating forces between particles. Virtual photons transmit the electromagnetic force. Virtual gluons bind quarks together inside protons and neutrons, and virtual W and Z bosons govern the weak nuclear force. Without them, particles would be unable to interact, and the universe as we know it would cease to exist. These ghostly particles, although transient, are the connectors of reality, the bridges that allow matter and energy to communicate, and the subtle engineers behind the stability of atoms and molecules. The most astonishing aspect of virtual particles is that they emerge from what we think of as empty space. The vacuum is never truly empty, it is a restless, energetic medium in which particle-antiparticle pairs constantly flicker into being and vanish. This phenomenon illustrates one of the most counterintuitive aspects of quantum mechanics, that nothingness is not inert but teeming with activity. The energy borrowed from the vacuum allows these virtual particles to exist temporarily, and their fleeting presence produces measurable effects. For example, the Casimir effect, where two uncharged metal plates are drawn together in a vacuum, occurs because virtual particles create a pressure difference in the space between the plates. Such effects are subtle yet profound, revealing the hidden dynamism of the universe at its most fundamental level. Virtual particles also play a critical role in the behavior of atomic and subatomic systems. They contribute to phenomena such as the Lamb shift, a tiny alteration in the energy levels of electrons in hydrogen atoms, and the anomalous magnetic moment of the electron. A slight deviation from predicted values caused by the influence of these invisible fluctuations. Without virtual particles, our precise measurements of atomic behavior would not match theoretical predictions. They are proof that even entities that exist only for infinitesimal moments can leave a lasting mark on reality. Moreover, virtual particles are essential in high-energy physics, particularly in particle accelerators where collisions between protons or electrons create conditions under which virtual particles can manifest more dramatically. These experiments allow scientists to test the predictions of quantum electrodynamics, quantum chromodynamics, and the Standard Model itself. Virtual particles remind us that the universe is not merely a collection of static objects but a dynamic, constantly interacting web of forces, where even the vacuum itself is alive with activity. The presence of virtual particles challenges our classical understanding of cause and effect. In a world governed by these ghostly entities, energy can fluctuate, interactions can occur without direct contact, and forces are transmitted in ways that seem almost magical. They blur the distinction between existence and non-existence, showing us that reality is probabilistic, ephemeral, and deeply interconnected. Even though virtual particles cannot be directly seen, their fingerprints are everywhere. Subtly shaping the cosmos, stabilizing matter, and ensuring that interactions unfold according to the hidden rules of nature. In the realm of the quantum, virtual particles are the invisible architects of everything we perceive. They are the silent facilitators that allow forces to act, energy to transfer, and matter to maintain its structure. Without them, quarks could not bind into protons and neutrons, electrons could not orbit nuclei in stable configurations, and atoms could not exist. Their fleeting presence sustains the universe, a constant reminder that even the briefest existence can have eternal consequences in the grand tapestry of reality. Contemplating virtual particles is to contemplate the universe's subtlety, its complexity, and its hidden beauty. It is to recognize that the vacuum is not empty, that forces are carried in invisible whispers, and that the smallest flickers of existence can shape the cosmos in ways that are profound and enduring. They are ghosts, yes, but ghosts that hold the universe together, orchestrating interactions with a precision and elegance that define the hidden order of reality. In essence, virtual particles are the silent, unseen choreographers of the subatomic world. They operate behind the scenes, ephemeral and fleeting, yet indispensable. They teach us that the universe is not as solid or predictable as it appears, that the vacuum is alive, and that the deepest truths of existence reside in the interactions of particles that never truly settle. By understanding virtual particles, we begin to perceive the hidden dance of the cosmos, the dynamic undercurrent of energy and force that sustains every atom, every star, and every living being. In their ghostly, transient existence, virtual particles reveal the subtle, beautiful, and astonishing architecture of reality itself.